Hello and welcome to Online Pathshala. Today's topic of discussion is congruence of triangles, and we would be discussing how we can say that the two triangles are congruent to each other. To recall that when the two objects are an equal copy or an exact copy of each other, we say that the two objects are congruent to each other. So today we'll see how do we denote the congruence between the triangles. Let's say there is a triangle ABC and a triangle XYZ. If you can see that by a trace copy method, we just trace this back on XYZ, triangle ABC on XYZ, and we would see that they are an exact copy of each other. So to say that, if we overlap A on X and B on Y and C on Z vertices, as well as the corresponding sides would also be overlapped, AB on XY, BC on YZ, and AC on XZ. If we put like this, the vertices A on X, B on Y, and C on Z, and we find that they are same, of course by seeing itself we can say that they are almost an exact copy of each other. In that case, we say that triangle ABC is congruent to triangle XYZ. Now, the most important thing here to remember is triangle ABC is congruent to triangle XYZ only on this correspondence. When A is lying on X, B is lying on Y, C is lying on Z. To explain this in more detail, let's say that if we have a correspondence of A lying on X, but instead of B lying on Y, B is lying on Z, and C is lying on Y. In that case, the triangle would appear more like this. So here we will have our A. If you see, B is lying on Z, so V will be here, and C is lying on Y. If you see that this is not an exact copy of XYZ, so in this case we say that triangle ABC is not congruent to triangle XYZ. But just by saying that ABC is not congruent to triangle XYZ, it's the same statement which we have earlier made, that triangle ABC is congruent to triangle XYZ. How can we deny this? So we have to say along with that the correspondence, how each vertices are lying. So we say that triangle ABC is not not congruent to triangle XYZ with correspondence of A being lying on X, B being lying on Z, and C being lying on Y. But triangle ABC is congruent to triangle XYZ with the correspondence that A lying on X, B lying on Y, and C lying on Z. To represent this, we say that if triangle ABC is congruent to triangle XYZ, the corresponding angles and the corresponding sides are equal. Now, what are the corresponding angles here? Corresponding angles. The corresponding angles are angle A and angle X, angle B and angle Y, angle C and angle Z. So these three angles will always be equal to each other, as well as the corresponding sides. What are the corresponding sides here? The above, AB and XY, AB, this is AB, this is XY, BC, YZ, AC and XZ. So AB and XY BC and YZ, AC and XZ. So we say the corresponding sides length are equal. So to say that triangle ABC is congruent to triangle XYZ, we say that the corresponding angles are equal, corresponding sides are equal, as well as the correspondence ABC lies respectively on XYZ. So basically, even though there is a triangle ABC which is congruent to triangle XYZ, but the correspondence is equally important, where on what the triangle ABC falls on triangle XYZ. If it is a correspondence in the first, what we have seen, A corresponding to X, B corresponding to Y, and C corresponding to Z, then they are congruent to each other. While in other case, that when A is corresponding to X, B is corresponding to Z, C is corresponding to Y, they are not congruent to each other. This is for today. In the next video, we'll see the criteria for congruence of